Today I'll be talking about how to find the inverse of a function. Inverse functions are functions that undo each other, and the x and y, or the input and the output, are flipped. So number one, f of x equals negative 2x plus 5. In general, how to find the inverse. We want to write y equals instead of f of x equals. And then we can go ahead and solve for x. I chose to do this step next because we're used to solving for x usually. However, you may switch the variables first, so these steps 2 and 3 can flip, doesn't matter. But let's go ahead and solve for x. So we're just going to subtract 5. And divide by negative 2. I'll take that x over to the left side. And for this class, it's okay if you don't simplify. It's really not a big deal. I'm just going to leave it looking like this. My next step is that this is our new function. So this side over here becomes our new y, or our new g of x. So you might want to call it g of x or this inverse function notation, but I'll be using g of x. So this again is our new y. I'll just skip right to calling it g of x. And the y is now our new x. We flip the input and output. By the way, I'm just going to go ahead and go through all these algebraically, and then we'll take a look at the graphs at the very end, so skip to the end if you're more interested in the graphs. But let's do number 2. We're just going to add, first write y equals. We're going to add 1 each side. And how do we undo a 1/3 in front? We'll multiply each side by 3. You can leave those parentheses, or this is a pretty easy one to just distribute. So over on the right side we have a 1x, but I'm going to bring that now to the left. And then over on the right side we're going to have 3 times y is 3y, and 3 times 1 is 3. So we have 3y plus 3. Again, this is our new function, so this is our new g of x. The y is now our independent variable x, our input. Number 3, we want to be able to undo a square root, so let's square each side. Forgot to write y equals, but that's okay. That's going to be y squared equals x minus 4. The root sign, the radical sign, goes away. Now we just have to add 4 each side to solve for x and get x by itself. And I forgot that I like to put that on the left side to show that this is our new function, g of x, and now our y is our x. Number 4, before getting rid of that radical, let's divide each side by 3. This should be a y, so y over 3. Equals cube root of x minus 4. Undo that cube root by cubing each side. Again, you may just leave those parentheses, don't worry about simplifying. The radical goes away. To get x by itself, add 4 each side. I'll write my x on the left. X is by itself. I'm just taking it over to the left side, and then we have y over 3 all cubed plus 4. This is our new function, g of x. This is our new input, x. There we go. Number 5. I'll remember this time, right? Y equals first. Divide by -2 each side. Undo that undo the fifth root by raising each side to the fifth power. The radical goes away then. Subtract 7. And now we have our function by itself, so I'm just going to write x equals, we have our x by itself. But this is our new function, g of x. And our very last one. How do we undo 2 over 3? It's really times 2 and divide by 3, so we're going to do the opposite. We're going to multiply each side by 3 and divide by 2. You're multiplying each side by the reciprocal there. 3/2. So again, 3/2 y. Now that fraction just disappeared. That's really nice. And we can undo the third power. We have to cube root each side. Last step, subtract 1. I'll flip that x over to the left side at this point. Being very careful how I write this, that -1 does not go under the radical. And now we have our new function g of x. So you might spot an error right here. It's pretty common for me that I forget to make that into an x. So right here, easy enough to correct. For number 5, that should actually be an x right there. So let's take a look at some of the graphs next. Going back to number 1, they're both linear. I already drew in a dotted line to represent where that line of symmetry should be, or that line of reflection for at the line y equals x. And taking a look at the graphs, I have both of them right here. They don't look quite, perfect, but that's because it's because the window isn't quite right. So just always go zoom 6. It should square it up a little bit, make it look a little better. And we just need to sketch these. So now you can see that reflection going on right down the middle. Oh, geez, these are I have a hard time sketching these as well. Yeah. Ooh, no, that was not good. So they should really intersect right here in the middle. So a little bit more like that. That's better. All right, let's do the next one. Here we have our two lines. They intersect at a point right down here. So maybe put the point where they're going to intersect, which should be on the line y equals x. And go ahead and sketch those. Better this time. Number 3, this one is a little tricky. They don't look like reflections, but that's because the square root function is only defined for to be positive. So it's only going to happen here basically in the first quadrant. We're just going to focus on the first quadrant. So we've got part of a parabola up here, and then we've got the reflection. Those are actually easier to draw. Number 4, okay. These ones we've got a lot of points of inflection going on, a lot of kind of squiggles, so a little bit more challenging to draw for some of us. Nice. And so, yeah, I'm telling myself I did a good job. So right here, they intersect on that line y equals x. All right, 2 more. Whew, all right, they intersect down here. And so I start to think about what these look like. We've got one, the fifth root function. It's a little like this. And then the fifth power function is a little like this. Decent. And here's our last one. Again, they intersect down here. And we have our third power. It's going to look a little like this. And then our third root is going to resemble